Today we're going to look at optimization, the process of finding minimum or maximum values using constraints. Let's look at some guidelines or steps. First, you want to identify all given quantities and quantities to be determined. 2. Write a primary equation. That needs to be maximized or minimized. 3. Reduce the primary equation to one single variable, which may require secondary equations. Make sure the answers make sense. And now let's look at an example. Say we have a box with a square base. And we know its surface area is 108 square inches. Or we want to maximize the volume of the box so it has a surface area of 108 square inches. So we're trying to find the volume. So the volume is going to be equal to the base. Since it's a square, it's x squared times the height. And we know that the equation for surface area is equal to x squared plus 4 times the height times x. And we see we have an h here, so we can solve for h. So h is going to equal to s minus x squared over 4x. And that's our h. So we can substitute it in. V equals x squared times s minus x squared over 4x. Which turns into x over 4 times s minus x squared. And s sorry, this should all be A, which for surface area. So now we can sub that in. Which turns into now that we have our equation to one variable, we'll differentiate it. Or sorry, we'll just solve for x. Oh yeah, well, no, we will differentiate and then to find x. So this will turn into 27 minus 3 over 4x squared equal to 0. 27 equals 3x squared over 4, which turns into x squared equals to 36. Take the square root. X will equal plus minus 6. Since you can't have a negative length of a box, x is equal to 6. Now we can find our height by plugging it into the original equation we had here. 108 minus 36, 6 squared over 4 times 6 equals 3. So the volume to maximize so the maximized volume will be 3 by 3 by 6 inches.